Hey there, welcome back to Coding at Home with the Code Hub. I can talk today. Hey, I think I might be a bit traumatized from Swan's Quest Chapter 2. The adventure gets a bit more exciting. Hopefully you've had a chance to watch the video at this stage and download Chapter 2. If you haven't, don't worry about it. We're going to walk through it today. And if you have and you've tried it out, also don't worry about it. We're going to walk through it today. We'll explain some of the code to you, as it is a bit of a step up in terms of coding knowledge. There's a lot of advanced techniques in there, and we'll show you where to go to look for help if you ever get stuck. So let's jump over to the iPad, and we're going to try something a little bit new because we're going to have our audio playing here. So let's jump on over and check it out. All right. So if you didn't yesterday, you should go off to Safari and go to the codehub.ie/playgrounds. And I noticed that my screen isn't updating there, so let's take a look. It would help if I were actually showing you what's going on. All right, so this is where we're going to go. We're going to go off to the codehub.ie/playgrounds. We're going to hit go. That link will be in the session description. We are going to tap on, this is the thing that we're using today, is this subscribe to the WWDC feed. And when you tap on that button, it'll launch Swift Playgrounds for you on your iPad. We can say subscribe to the Swift Playgrounds from WWDC. And it'll tell me that I'm already subscribed. But it's handy because it's already opened up the more playgrounds for me. So I'll scroll down to the bottom. Way down to the bottom. And we'll see that there are now 3 playgrounds available. And we'll hit see all so we can see all of them. We have WWDC Quest Create. That's the blank playground they have. This sort of a starter game template that we'll talk about a little bit at the end, and maybe more next week. We have the one that we worked on yesterday, Swan's Quest Chapter 1, where we used voiceover to solve the puzzle. And this is the one for today, Swan's Quest Chapter 2, A Time for Tone. So we're going to hit get on that and download it. Now, again, if you're not sure where I'm getting these from and what I'm talking about, Swan's Quest, if you've just joined us, I'm going to go out to the developer app. So the developer app I have downloaded here. So over here in the collections tab in my developer app, there'll be a few different collections. The one I'm interested in is WWDC 20. And I can scroll down. There's a whole bunch of interesting stuff in here. But the one that we're interested in is taking Swift Playgrounds to the next level. So we're going to tap on that one. We can see a few sessions coming today. This one ought to be exciting. Building a Swift UI view in Swift Playgrounds. That might give you some more ideas for how you might build an app in Swift Playgrounds like we were doing a few weeks ago. But we're going to tap on Explore Swan's Quest. So we did Chapter 1. We're now on Chapter 2. So the really nice thing, and the reason why I'm showing you this, is because this is going to help us figure out how to solve these puzzles. These sessions this year are available all for free for everybody. But you can watch the video here. You have an overview that explains a bit about the particular session. You have some tags that jump you off to the forums where you can discuss this particular session. Or Swan's Quest in general, so any of the 4 sessions about Swan's Quest. And this is where you can download a zip file of the playground books that we're working with. You also get the transcript of what's being said inside the video, which is excellent. And this is a nice short one. This is 5 minutes. And then this tab over here, the code tab, will show us the code that they show on screen in any one of the sessions. So if you're looking into more information about AR Kit or Reality Composer or what have you, anytime they reference code, you can now go in here and copy it straight out of this developer app. So this is how we would play middle A. It'll jump to that point in the video. And then we can just tap in here and select a whole chunk of code. This is a great way to play around with code that maybe you're not super familiar with and that you'd like to learn a little bit more about. Because we could copy this, put it in our playground, and try to run it, and then try to break it. Because that's one of the best ways to find out how something works, is to go off and break it. So keep this in mind, because we're going to be coming back to this in the middle of this session. So we're going to go back to Swift Playground. So I'm going to exit out of that. I'm going to open up Swift Playgrounds again, and I'm going to tap on my newly downloaded Chapter 2. So it tells me it comes from a third party. We definitely want to open it. Okay, so we're back talking to the lizard again. So we'll hit run my code to find out what it is we have to do in this playground. Because that's our only instruction at the moment. Just it says touch run my code to continue our quest. We have this tone output thing here. And if you watch the video, they explain that the tone output is a class that will help you play music. So we're going to press play. And there we go. Our turtle's off to talk to the lizard again, bringing the scroll that we got from the previous playground. And there it is. You can see if we tap here. So I had you take a screenshot of those notes, or the numbers, these numbers anyway, yesterday, just in case. But we now have them inside this playground as well. So the lizard tells us this is a gift from nature itself. Let's take a look at this. It's coarse, and it tells us that these numbers represent frequencies of different sounds. And the lizard is telling us it's not just any sounds, they're musical notes, like do, re, mi. In fact, they're for the C major scale. Now, this is where I personally get a little bit lost, because I'm not the best musician, and I'm not quite sure what's going on with the C major scale or any of the other musical scales. But that's all on me. Hopefully you have a bit more musical knowledge than I do. And it has a note here saying, see how the first number is exactly half the last number. So 261.63 is exactly half of 523.25. I'm going to take the lizard's word for it. And I'm going to tap next. So the lizard is telling us it appears the swan wants us to perform this scale for her. And the lizard knows just the spell to use. We can use a tone output. So we're treating this class like a spell almost. So the lizard says we can turn these numbers into an array, then use a timer to loop through them. So this is a bit of code here. Timer, scheduled timer with time interval. Now we've seen this. It just looks like a function on a type. So we're going to add that into our performance function here. Because what's going to happen is this performance function is going to get called. It's going to run our code. And then we tell the owner that we're ending the performance so it can assess how we did. So we're going to create a timer loop. And we'll need to play a tone. All right, so let's try that out. So let's go back for a second. And let's look at this timer.scheduled-timer. Let's start typing that out. Now there's a whole bunch of things in the autocomplete bar. It would take me forever to get over to the T's. So let me just type T for timer. There it is. It shows up in my autocomplete bar. So I'll do timer dot. You can see scheduled timer with time interval. Okay, so we'll go over here. I'll actually start typing SC. Here it is. Scheduled timer with time interval. Repeats, and then there's this block thing at the end. We'll talk about that in a little bit. So the time interval is just when this thing is going to fire, this timer is going to fire. So we will have it fire right away, I suppose. We can say whether or not it repeats. So the timer would reschedule itself to fire again in a little bit. So let's tell you what, let's not do it in 0 because that would be a little crazy. Let's do it in 0.4. We'll say false because actually we'll just play one note for now. And then in this block, we're just going to hit return. This is a funky looking syntax. We've got a timer type inside parentheses that looks like a parameter. We've got this arrow and void. This kind of looks like a function that we might write, except we're missing the function name. And in fact, that's kind of what this is. It's an unnamed function or a closure. So when I hit return, some magic happens here. So the parentheses actually moves up to the end of my false for repeats. I get a brace here. I have to name my timer parameter, so I'm just going to call it timer with a lowercase t. And that says in and then code. And this is going to be the code that repeats inside the timer. Now this is an advanced bit of coding here. We haven't touched anything like this yet. And maybe when we get into the Sonic Creates workshops and playgrounds, maybe then we'll play around with some more. I haven't played with those playgrounds a lot. But this is a hugely powerful one and something that you might want to use inside your playgrounds because it'll allow you to write some code and have it run at a later time. All right, so now we want to write some code in here. And if we go back to, because if I try running this, I'm going to have an issue because that's a placeholder still. So let's run well, we can't run our code. Let's tell you what, let's comment this one out. Because we can't see our instructions because we need the playground to build for us to be able to see the instructions. So let's press play. We see the turtle go up and talk to the lizard again. All right, he looks at the thing. He tells us it's frequencies of different sounds. C major scale. Tells us about tone output. There's our timer. So inside this timer loop that we've just written, we need to play a tone. So we're going to write code on the left like so. Let middle A equal, and then we're going to create a tone instance, right? This is a type, and this is an initializer. And we initialize a tone with a certain pitch and a certain volume. Now, if you want to be really obnoxious, you could set the volume to something higher than 0.3. You could set it to 1.0 and see what it sounds like. But inside the timer, we're just going to have it play that and see how we get on. So let's do that. Inside the timer loop, we're going to hit return using this key down here. We're going to type let middle A, and we're going to have it be equal to, let's go find tone. We're going to start typing tone. We're going to use this initializer here. We have two options, this from decoder or the pitch. The decoder would just read a tone instance from memory, from disk or from somewhere else. You have it saved somewhere. So let's see, middle A's tone was 440.0. So 440.0 rather. The volume, we're going to be sensible. We'll use that 0.3 for our volume. And now that we have a tone, we can call this play method on our tone output. So now I'm going to go get my tone output. Tone. If I start typing, I'll see tone output. I want to make sure that I pick this one with the lowercase t because that's my variable, not this. This is the type. Just so tone output dot play, and there's a few options. There's play tone, a single tone, and then play an array of tones. So we're going to pick this one because we only have one tone. We'll call this middle A. Okay, well, let's try running this. All right, we'll go hit play. We go to the lizard's house again. We're going to hand him the scroll. He takes a look at it. Says there are different frequencies of sounds. C major scale. We're going to use a tone output. Cool, we're on that. We've set up our timer. We have no build errors at this stage. We're going to practice that now. So we're going to hit the next arrow. And we'll see if my sound is actually working here. Okay, so it didn't run yet. Well, what's going on? Let's check it out. Maybe let's have it repeat. How about that? Let's change it to true and let's try running it. We're going to hit play. There we go. Lizard's taking a look. Frequencies of different sounds. C major scale. Tone output. There's our timer. Okay, everything looks in order there. All right, we're going to write some code that looks like this. Okay, we did that. We're going to practice it now. Okay, I'm not hearing anything. All right, so let's go have a look at the code that they wrote in the developer app. Right? If we get stuck, and you may be stuck at this stage, let's back out. Let's open up the developer app and let's see what they wrote here. All right, well, they have this code here where it just plays one note. We have this dispatch queue main async after. Okay. So what this does is if we read it, we get a tone output. We create a note called A4. We play that note. And then we have this thing that basically says, hey, it's almost like our timer, maybe a little bit less friendly than our timer, this main async after. It basically says, hey, after now plus 400 milliseconds, I want you to call this tone output stop tones. Because if we write this code, and let's go grab it, we're going to copy and paste that. So we'll tap on let. And we will try to select that. There we go. We'll copy that. We'll go back to our Swift Playground. And for now, let's just delete this. We'll select that as text. We'll actually delete all of this. And inside our performance, what we're going to do is we're going to paste this. And we'll run our code now. So there, we'll press play. The turtle goes to the lizard. Takes a look at the scroll. Frequencies of different sounds, C major, tone output. Okay, we're not going to do that for now because we're going to use this pasted code that we have in here. We're going to practice it now. Okay, so I'm still looking at sound for crying out loud. Let's try that again. I'm going to run my code, and we're going to try that again, this time with the sound on, so hopefully you can hear it. Maybe you did hear it. It's just me because I don't have it turned on my Mac. So here we go. We bring the scroll again. We look at it closely. Frequencies, C major, tone output, scheduled timer. So now we're going to practice that. Excellent. Okay, cool. We just played our one tone. So now that we've managed to play a sound, because that's all that they were looking for this particular playground, now the adventure continues on the next page. Now we might go back and tweak this later and say, all right, well, let's play around with these different parameters. Let's change the deadline for this task to run. Because basically what it's doing is you can imagine it like it's a set of water slides, and there are 3 water slides at the park. And till now, we've only been running down the one water slide. So we have a giant line of kids all lining up for that middle water slide. And we all have to wait for everything to go down the water slide. Well, this dispatch queue says, actually, we can start sending people to the other water slides on the edges. So what we do is we send this task here where we stop the tones. We say, all right, cool, just wait 400 milliseconds so that we don't land on anybody below. Wait 400 milliseconds and then run this command, stop tones. That's kind of what we're doing here with this dispatch queue. Because if we had called stop tones right away, it would play this. We would barely hear this because the iPad is going to process it so quickly. It'll call this play, it'll start playing the tone and immediately stop all tones. So we'd never actually hear the sound. It would be working, our code would be running, but we wouldn't actually get the desired result. So let's go on to the next page. Let's hit this arrow here. All right, so thankfully, the lizard wrote down the scroll numbers for us. So these are the numbers from our scroll. It looks like, well, let's see what we have to do. Let's hit run to find out what it is we have to do. Okay, so we're in the Great Hall with the Swan. Welcome back. We came back so quickly. Did we have any trouble? Nope. All right, so every bird in my kingdom learns these at a young age. Unfortunately, see, that's why I didn't learn it. I'm not a swan in the Swan's kingdom. So are we ready to show the Swan what we figured out? Okay, well, we've we failed because we haven't written any code yet. So now what we want to do is let's go take a look at the other code that they had in the developer app. So we did a good job back here using this dispatch queue. But if you watch the video, the guys talk about playing more than one tone, like here. So again, we have a tone output. We have an array of tones. So you can see these two brackets here and all these tones separated by commas. That's an array of tones. We've done that back in the Everyone Can Code puzzle sessions. And then we're going to have a variable called tone index that we're going to keep track of. And we're going to start at 0. Because if we're looping through an array, then we want to make sure that we're keeping track of our the number of items we're on. And the reason why we use the index to loop through our... Hold on, where's our array? The reason why we'd use this index here to loop through our array is because we're comparing and we're seeing if the index is larger than the number of items in the array. Because if it's larger than the number of the items in the array, that means we've looped through everything in the array and we should be done. So there's this cool syntax here. This guard syntax is sort of special to Swift. It's what makes Swift a fairly safe language. Basically, it's another way to test. It's like an if statement, except with a guard statement, if the statement evaluates to false, we get out of there. We're done. Now, this is great in the case of this, where we're looping through something. Now, when we want to stop, we have to do this thing here. We have to invalidate the timer. We have to stop the tones so that we're not constantly playing the last tone that we told it to play. And we tell the owner that we're done performing so they can evaluate our performance. So that's why this guard statement is hugely powerful. I know when I first came to Swift a long time ago, it was a little bit of a mind shift for me because we didn't have that in Objective-C, which is what we used to use to write iOS and Mac apps. But I actually really like it because it lets you write code to get out early. If you check and say, okay, I'm going to run some code, but let me just check to make sure everything's set up. If you decide everything's not set up, then you can say, actually, don't bother even looking at the rest of the stuff. Let's just get out of here. It makes things kind of easy from a control flow point of view that way. All right, so this code looks like it might help us play all that array of tones. So let's go grab this. Let's say, all right, we'll grab the tone output. We're going to copy all of this. we're going to go back to Swift Playgrounds. We'll go to our second page. Remember, I had gone back to our advice from the lizard. I'm going to go back to performance at Swan Hall. And then we're going to grab this and replace the tone output too, because we have, or actually here, tell you what, let's just do it under here. Let's paste our code in here. So we have an error because we've defined tone output twice. So we can delete one of these. Let's delete the new one that we just pasted in. Okay, all right, so we have our tones. Now these aren't all the tones. And in fact, if we run this, let's try running it just for kicks and see how we get on. All right, there we go, up to the swan. Asked if we had any trouble. Every bird, are we ready to show? Let's try it out. Ooh, all right, well that sounded kind of cool. We had these, it played these 3 notes and then it was done. The reason why we don't need a loop here, can you guess why? Go on, just shout out your answers. Okay, well, if you, hopefully you got the right answer. This is a scheduled timer. This will actually repeat this code for us. So everything inside this block will repeat. And what we do is after we play a tone, we say, okay, well, let's take the tone index and add 1 to it. So for the first, we say, all right, let me get the tone at index 0. That's the first one because we start counting in arrays at 0. So it plays this note first. And then after we play it, we add 1 to tone index. So now it's 1. And when we say, hey, give me the item at index 1 in tones, it gives us this one. And then the same thing, we get the next time we go through, it's 2, and so we grab this one. And then it's only when tone index is 3, we get here and it says, hey, if tone index is not less than the tones count, we need to execute this code here. So we stop all tones, we invalidate the timer, which means it'll stop repeating, and then we tell the owner that we're done with the performance. So let's fix this. Let's add a few more tones here. So I'm going to take the numbers right from here. And there's a few ways you could do this. This is nice because they have an array for us already. We could actually create a loop to build this tones array. But let's do it the kind of brute force way. So let's say, so instead of 440, we'll start with 261, 61.63. The next one will be 293.66. 293.66. And if you're like, where is he getting these numbers from? It's just up here. These are the numbers from the scroll. So now we need 329.63. So 329.63. I need to add another item to the array because we need to have all of these in here. We need to have 349 all the way up to 523. We can add other items by tapping on the end and saying add item. So I'm going to do just like I'm going to actually organize it just like they've got it organized. We'll create a tone, pitch. We'll use the same volume for all of them. We won't have them go up or down. Let's see, our next one is 349.23, 349.23. That's not going to work. We have to tap on the pitch, and we're at 349.23. Now, the other way we could do it, instead of adding it using the add item contextual menu, we could actually tap on this whole thing and copy it. Put a comma here. So we'll bring up the keyboard and put a comma, because anytime you add a new item to the array, you have to separate them with commas. The only one that doesn't have a comma after it is the last item in the array. Actually, while we're here, we need to have how many more? So we've got to have one for 392. 1, 2, 3 more. So let's do 3 more while we're here. Oops, missed. So we'll put another comma, return. I'm going to paste in that same number, comma, return. I've already lost count of how many I needed. We'll do comma, return. We'll fix it after the fact if we need to. Let's hide our keyboard. All right. So we have 349.23. Now we need 392. So we'll bring up the keyboard. So 392.0. The next tone is going to be 440.0. Actually, 00. It doesn't matter. We'll leave the other one that way. 349.23. We got to replace that with 493.88. So 493.88. And then our last one is 523.25. Okay, cool. All right, I managed to count correctly. Great. So we have our array of tones that match the numbers in the list that we were given on the scroll. Let's try running it and see what the Swan says. All right, here we go. We're approaching the Swan. Did we have any trouble? Not too much. All right, let's show off what we've learned. So we're going to hit next. All right, we did it. Now, even though it said you're so close to the beginning, we did it. So we passed the Swan's first challenge. So now we're ready for something more complex, and the Swan is giving us another scroll. Let's take a look and see what's in there. Okay, all right. So me as a musical non-genius, I'm in a lot of trouble for this next challenge. But cool, this is cool. For those of you who can read music out there, you're thinking, oh, this is great. I can handle this next challenge. So tonight at 6, they're going to launch the next chapter of Swan's Quest. We'll be watching it again. We'll add the playground to our playground feed so that we can get set up for tomorrow. And we can go through this all again. So the music on this scroll is a favorite tune of the Swans. She would hum it as a child, especially when Alfred swims in her parents' lake. So we have to study that and then come back when we're ready to perform in this hall. She's going to await our return. Now, they gave a side challenge, a side quest in the video where they asked you to play the F major scale. Now, I have no clue. They gave you the way that you need to calculate it. But I'm not 100% sure that I would get it right. I think it starts at F, which is, I think, 349.23. But I'm not 100% sure. So now that we've finished the main quest here, let's go back to the developer app. And if we go back to the overview, so that's, we used the code. This was great, having this code copy feature. If we go back to the overview, we can search the forums for this tag. So if we do that, we'll get sent off to developer.apple.com. And we have a few other people. We have some people who have a side quest solution, and then someone else who's stuck with their code. So let's have a look at the solution. All right, so this is what someone wrote this out. They actually kind of spelled out the C major scale and the F major scale. Now, I could look this up on Wikipedia, and in fact, that's probably what we should do, what the scale is and what the notes are, and then figure out the frequencies given the formula that they gave you during the session. But this looks very like our code. Now, they've got the C major frequencies, and this has got the C tones and the F tones. Okay, so it winds up playing right now. It just plays the tones from the tone index. So whichever tones we're using, in this case we're using the F tones, this would play the F major scale. So this is definitely worth worth going and having a look. I won't go and copy and paste this into our playground and try it out, but you could definitely go off and do that. If you want to not mess up your own code, what you could do is grab a new copy from our playground feed, and that way you can work on the side quest solution in another playground. That's not bad. That's not a bad idea. Now this is a little bit more advanced. We've got an enum here, which is something that we haven't seen, but it's a really great language feature of Swift. If we go back to the forums in general, there's a whole Swan's Quest forum. And the engineers at Apple have been commenting on some of these as well. So if we tap on Swan's Quest, we can see that we get some replies from, well, people like me, but you also get replies from the Apple engineers, and they encourage you to look at Swift enums for chapter 3 and 4. So it sounds like we're going to have to learn a little bit about those for the next few challenges. I want to congratulate you if you got this far. This is not super easy. There's a lot of really impressive code in here. It's presented really well. I really liked the way it's presented with the little story behind it. But it's a good chunk of work, and there are a lot of new. Now this isn't that new. We know about creating arrays and creating instances of types like tones. This timer stuff and dispatch queue stuff is brand new and fairly advanced. You're doing some pretty serious application development if you're learning about dispatch queues and timers. So I want to congratulate you for getting this far. If you were frustrated with today's lesson, take some time and go over their video again. Watch this video again, because hopefully we walked through it slowly enough that it made a little bit more sense. And if you can get those tones playing and get that Swan happy, try playing around with it a little bit. The best way to learn, especially when we start diving in the deep end like this, deepish end, is to play around with it, break stuff, and see how it breaks. Because often how stuff breaks and the messages you might get from Swift when you get those little red dots, they might help you understand, okay, all right, I can't use it like that. But we did hit a lot of new features today. Closures is a really big one, where we had a function that didn't have a name inside of our timer. That's a huge new concept. Hopefully the idea of a water park and having multiple water slides helps you a little bit. It also works for dry slides. If you're at the top of a platform and there are dry slides, that analogy would also work. So hopefully that helped explain a little bit what was going on. But we'll see you back here tomorrow anyway for chapter 3. Check it out. Check out their video. Ideally, you would like and subscribe. I feel like a kid saying that, to this YouTube channel. And we'll be back with you tomorrow. All right, see ya.